Welcome to our video tutorial on the geometric interpretation of parabolas. As we saw in class, we can look at a parabola as y equals x squared over 4c. When we look at a parabola like that, it has its vertex at the origin, 0, 0. It has a focal point at the point 0, c, and it has its directrix at the line y equals -c. So if we gave a very quick sketch of the situation, you have a parabola like this. We have its vertex at the origin. We have a focal point at 0, c, so that the distance from the vertex to the focal point is c. And then we have a horizontal line that is also a distance of c away from the vertex. So the horizontal line would be at y equals -c. So in this situation, if we want to figure out the focal point and the directrix of a given parabola, we really focus in on the part with the x squared. So in this scenario, we would set up an equation of the sort that 5 has to equal 1 over 4c, because the 1 over 4c is the coefficient attached to the x squared. Now we could cross multiply to solve this. We would get 20c equals 1, or c is 1/20th. Now keep in mind that is the distance we go from the vertex to get both the focal point and the directrix. So this particular parabola would have had its vertex at 0, 7. We would go up 1/20th to get the focal point. So the focal point would be at 0, now 7 plus a 20th would be 141/20ths. Please try to leave it as simplified improper fractions whenever possible. And the directrix would be down 1/20th from our vertex. So the directrix would be at y equals 139 all over 20. Let's move on to our next problem. But notice in this problem the negative coefficient attached to the x squared. That means that in this particular scenario, the parabola is opening down. So the focal point will actually be below the vertex, and the directrix is actually going to be above the vertex. First of all, let's identify that the vertex on this problem is at 0, 10. To find the c, we would set -3 equal to 1 over 4c. We could multiply both sides by 4c and get that -12c would be 1, or c is a -1/12. The negative just indicates that the focal point is below the vertex. So we start at the vertex of 0, 10. We're going down to get the focal point. 10 would be 120 12. So 10 would be 120 twelfths. We're going down 1. So this would be at 119 twelfths. The directrix, on the other hand, goes above the vertex. We would be up 1/12, which means y is going to be 121 twelfths. We're going to do 4 more problems, hopefully getting everybody the bearing on how these work. So now we have to look at the coefficient attached to the x squared. We know that 1 over 4c has to equal that number. So -4 equals 1 over 4c. When we cross multiply, we'll get a -16c is equal to 1, or c is -1/16. This particular parabola has its vertex at 0, 5. It's going down, so the focal point will be below the vertex. 5 minus a 16th. So 5 would be 80/16. We're going to be down to 79/16 in this problem. And our directrix would be up 1/16 from the vertex, so it would be at y equals 81/16. Now on our next problem, we would need to complete the square first, because we need it to be in that vertex form. So we would factor out our 2. Remember our completing the square. This would be x minus 2, the quantity squared. That forces us to put a 4 here. And what we've really included in this problem would be a plus 8, so we'll have to subtract 8. We're only on one side of an equation. We have to balance it out. We'll have a minus 1. So now that we have the equation of our parabola, we take the coefficient and we set that equal to 1 over 4c. So 2 is equal to 1 over 4c. From there, we would get that 8c is equal to 1, or c is an eighth. Now be careful. This parabola has its vertex at 2, negative 1. It's opening up, so the focal point will be above the vertex. Has the same x-coordinate. We're going up an eighth, so it'll be at negative 7/8. And the directrix, well, that line is going to be below our vertex. It's going to be down an eighth, so it'll be at y equals negative 9/8. Complete the square first, identify the vertex, and use your value of c to determine both the focal point and the directrix. 2 more problems that we will investigate. And here they are. Perhaps you want to hit pause and try them before we begin. First, we have to complete the square, so we'll factor out the 1/12. In this case, that'll be x squared plus 12x. Leave the 4 off on the side. This is going to be 1/12 times the quantity x plus 6 being squared. That means we have to put a plus 36 here, but what we really included then would be a plus 3. So we have to subtract 3, and we're going to have a plus 1. So here's the equation of our parabola. Now we're going to have to solve for c. So 1 over 4c is equal to 1/12. Perhaps you can see that the value of c will be 3 in this problem. So now identify our vertex. Our vertex was at negative 6, 1. This parabola is opening upward, so its focal point will be above the vertex at negative 6, 4. We're going up c. And then its directrix would be down 3, so it would be at y equals negative 2. In our other problem, we are going to factor out the negative 1/5. That'll leave us with x squared minus 10x, and then close your parentheses, minus 3 over on the side. That's going to be a negative 1/5 times the quantity x minus 5 being squared. When we square a negative 5, we get 25, but what we've really included would be a negative 5, so we have to add 5 to counter that out. Negative 3 plus 5 is 2. Here is the equation of our parabola. Notice that that parabola is opening downward. Its vertex is at 5, 2. Its focal point will need to be below the vertex, so its focal point, we have to solve for c. 1/5 is equal to 1 over 4c. We can put the negative in there if we want to. So we're going to get negative 4/5 c is equal to 1, which means c is a negative 5/4. So we're going down to get the focal point. 2 is 8/4, 8 minus 5 is 3. And then for our directrix, we're going up 5/4 from the vertex. That would be 8/4 plus 5 is 13/4. So again, complete the square, identify the vertex, calculate your value of c, look at where the parabola is opening, whether it's up or down, and use that to determine your focal point and your directrix.